Hey, good afternoon, everybody. My name is Nico Seatak. I'm going to talk about my research topic. My research topic consists of evaluating moisture testing methods and their impact on roofing performance. I think there's a problem. The research examines how concrete roof decks are tested for moisture before roofing systems are installed, and excess moisture in concrete is common cause of roofing problems as seen throughout uh, many years, including poor adhesion, premature roof failures. While the industry has already standard methods such as ASTM moisture test that are widely used and spec'd out today, there's a limited evidence that these tests accurately predict long-term moisture levels within the concrete, especially for a roof system. StudyWorks explore whether current test practices provide reliable information for future roof performance and the durability after the standard 28-day cure concrete curing period that the general industry uses. Research objectives to determine the existing standard if it affects low slope single ply roof system when they use to determine moisture content in a concrete slab. Overall, the research question that I compiled is, does the current industry standard concrete moisture testing methods, uh, ASTM D4362 and moisture encounter meters, predict long-term moisture conditions and help reduce moisture-related roofing system failures? I think that the project that uses the industry standard concrete moisture testing methods before roof installation will not only experience significantly fewer moisture related roof failures than the project that do not use the formal ASTM uh, test standard. This suggests that the current test methods that we currently see in specification may not be reliable in predicting long-term roofing performance or adhesion success. Um, uh, and uh, my literature review is based on moisture in the concrete roof decks. It's been known to be an issue in the roofing industry for years, mainly because it directly affects adhesion, the durability of it, and more so the long-term performance of it. Research There's plenty of research and case studies that's shown that moisture trapped in concrete can damage insulation and coverboard, as we've seen roof failures happen. It can also lead to corrosion, mold, loss in attachment over time. This issue has become more critical with flat roof systems, which is primarily what I'm trying to study. Um, where the low slope roof design, typically concrete is a concrete substrate without a vapor barrier, and that this design keeps water out by using a waterproofer layer that is intended to shed water quickly on top of the roof systems. Today, systems rely heavily on adhesives and fastener uh, inside the systems to keep the system intact. However, if those adhesives get moisture in them, they tend to fail super fast, um, and which causes a lot of roof failures. So, yeah, as I mentioned, moisture behavior in concrete decks is a hard thing to study. However, all concrete decks have water in them, whether it's a new concrete deck or an existing concrete deck, and understanding what's acceptable and how we test that deck to make sure it doesn't have too much moisture is critical to this topic. Um, that increases the risk of moisture related roof issues for sure. Slab may appear to be dry one day, but regain moisture after getting re-wetting or environmental exposure. Um, and what that means is, here in Texas in the summers, we have hot summers. We don't really get a lot of rain, and during our winters, we also it may get cooler, but uh, it still typically stays between the 50, 60, 70 degrees. However, somewhere like Washington, it rains all the time. So that slab is constantly saturated. And when the sun comes out for one day, slab may appear to be dry to the surface, but there might be a lot of moisture trapped inside the slab. Once you put a roof on it, it doesn't have anywhere to go but the roofing system, which causes uh, accelerated failures. Same thing in cold climates like New York, for example. After the 28-day cure time, the industry says that we are good to roof because of meet its strength, but strength has nothing to do with how much moisture is in there necessarily. So once you meet your 28-day cure, and the slab has been exposed to nothing but 20, 30-degree weather, may not have allowed enough moisture to evaporate, so it gets trapped in there. So once we put the roof on, same thing, we have an issue because the moisture tests are saying that it's dry, but it's just trapped in there. It's not coming out. And once the summer months come, the slab starts to breathe a little more. Where does that moisture go inside the concrete? And right now the industry has, and just to show you guys, right, like a single ply roof system is very common. This is what you typically see nowadays. It's your PVC, TPO, EPDM attachment methods, and they can be mechanically fastened, but we're focusing primarily on the adhesion part of it. There's also SBS roofs, which is a different roof system, same components, right? It just has a different top layer. There's also APP roof, same thing, same components, insulation, adhesive, just different top layers. The top layers don't really have an effect on how it fails. They all fail similarly. They all have seams one way or another. They're not monolithic systems. And why do we test these, right? It's not only for compliance with the manufacturers, but just provisions, right? We want to, in the absence of testing, we're going to have warranty issues. You can have structural damage, delamination, moisture mitigation, mold, and just all real world failures. It's just the roof blows off, right? And we see that on and on in different parts of the world. Testing these moisture things, right? So talked about that throughout the years that the industry used a 28-day cure time. And afterwards, the ASTMs have published several different test methods to mitigate how much moisture is in there and test it. However, they're all very different, completely different actually. So the ASTM, if you don't know, it's the American Society for Testing Materials. It's the organization developed these tests, and these three tests that I'll be focusing on is the ASTM 4363 plastic sheet test, the ASTM F2170 relative humidity probes, and the ASTM moisture meter and counter. And as I mentioned earlier, these are in specifications nearly on every project. And so just to understand these tests before conducting my research, right? So the ASTM 4360 plastic sheet test, it's a non-destructive test. You essentially take this plastic, 40 mil plastic, 16 inches by 16 inches. You apply it over a concrete slab. When it's dry, you tape it up. You come back 16 to 24 hours later. And the next day, if you see moisture inside the plastic, that's an indication that there's too much moisture concrete inside the slab. However, if you come back and there isn't any moisture in there, it says that it's a pass, right? It's a pass or fail test. And these are very cheap, originally designed for the flooring industry, but it got sooner or later adapted to the roof industry, and it's used in specifications now. This is just a quick image of what it looks like, what's done out there in the field. So you see the tape, the plastic, usually you date it, you time it. So you don't want to go beyond that threshold after the 16 to 24 hours because the test is no longer good. And you write down if it's a pass or fail. And then once it's a pass, you're allowed to roof that area after 500 square feet. Second test that the industry tells you to use is the ASTM F2170 relative humidity probes. This is a destructive test. It allows you to drill a couple holes inside the concrete slab. You insert these probes in there. You leave them for about 24 hours. You come back the following day with your moisture meter. That moisture meter reads a percentage of how much relative humidity is in there. And this test is more expensive, and it says it needs to be less than 75% to be considered dry. As you can tell, this test compared to the other tests, two different. And this only reads the center of the slab, doesn't read the surface on the underneath of the slab. And lastly, you have the ASTM F2659, it's your Trimex meter. This one's also a non-destructive test. It's when you take a moisture meter and counter, you apply it to the top of the concrete slab. It must be to the visible eye dry, and it gives you instantaneous readings, right? So it reads only about 3/4 inch of the slab, and it gives you a threshold where it's considered dry after 4.5%. The max is 699. Anything below the 4.5 is considered dry. And this is what's widely used right now as well. This is a picture of it. Once placing it on the concrete slab, it says 4.1%. So it's below that threshold. It says it's good. But keep in mind, it only reads less than an inch of that. And this is what you see in the field once the testing's done. If it has moisture, once the roof is installed, it read hot, which is kind of what we're looking at here. So let's talk about the research gap, right? So even that there's a lot of information out there on moisture and roofing, there's still a clear gap between the two. One of the major gaps is that there's not a clear definition of what is an acceptable amount of moisture, or is there a threshold that exists, especially beyond the 3 tests. The thresholds are different, and the allowable moisture content, one is not stated, 2, not all of them are on the same page. Many specifications require concrete to be dry, but they do not define the acceptable moisture levels in in a consistent way. So it just tells you to test, but it don't tell you what's considered dry. Another gap is the lack of long-term field data, right? So none of these tests actually have field verifications that, hey, this allows the roof system to work. That we don't have, that data does not exist. There's a limited research shown how test methods actually relate to. Most of the research show that the failures, or after the roof already failed after 10, 15 years, and at that time it's hard to pinpoint that it's moisture driven from the slab. At that point, it can be due to workmanship issues, just poor maintenance on the roof. It's kind of hard to pinpoint it on one thing. There's a lot of gap between the interior slab research and the roof system. Many moisture standards were developed for flooring, as I mentioned, right? So none of this stuff got adapted to roofing till only about 40 years ago. Roof decks behave differently than floors because they are exposed to weather and re-wetting. Unlike floors, once you have your walls up and you got a roof over your head and you have circulation in there, the slab breathes differently. You can control how much water gets inside the slab on a surface like the roof. When you have re-wetting and colder months, it's a little harder to do that. Because of these gaps, the industry is still relying on practice to not fully address the problem, and that's why we still see roof failures. To address this gap, the study purpose is to include developing a standard specifically that the roof decks, rather than relying on these methods that we have from the flooring industry. This study will define the acceptable moisture content in concrete defined by moisture encountered areas. This will kind of centralize the test methods for all flat roof systems over a concrete deck, or especially applied over a concrete deck. And the research design, right, we talked about the different methods, and what I intend to do is have 3 samples, which is a concrete deck 4 feet by 4 feet. Use the 3 ASTM samples that we have today. Once that concrete passes, based on the standard for each slab, install the roofing system and completely seal it. And month to month, come back to those samples and take real life data and see how much moisture is accumulating into the roof system with the test sample, that been specified, right? So, and that roof system I would keep on that concrete pad, the same conditions for about 6 months. So give me real data. If that's how I would to install the roof, it'll tell me, hey, if I installed the roof at 0% and it passed the moisture meter in 6 months, how much moisture is going to be inside that roof sample. So if I use that ASTM 4363, which is the plastic sheet test, and after 6 months, I went from 0% of moisture in the roofing, and now after 6 months, I have 3%. That tells me that it's gradually increasing, right? Simultaneously, if I use the moisture encounter, I think that, you know, maybe after 6 months, it's going to have 12% because it lacks reading the center of the concrete moisture rather than the other test method, which reads the center of the concrete, which is the relative humidity probe. So I think all these 3 methods will show that they're very inaccurate. They read different things. And more importantly, which of these methods will show that even if we use them, you're still going to get a lot of moisture, too much moisture inside these roof systems, which you will start to see delamination failures. I would open the roofs at that point, at that 6-month threshold, and start to evaluate it with the consultants. And that's kind of the test method I'm planning to do. And the research, may help bridge gaps and identifying the acceptable moisture content levels for standard industry practices. That's kind of the goal when installing low slope roof system over concrete substrate. This study will also build on past research, which we see a lot of, and focus on actual field performance after roof installation during a new roof installation over a new concrete slab, which is what we build on today. Many previous studies discuss moisture testing standards and accept the moisture limitation, but few of these studies examine how moisture readings relate to roof performance over time. That's something we don't have. By using moisture testing, field observation, project records, and interviews, this study provides more practical evaluation of the real world roofing conditions, and that's something we don't have. And I think that's how we can bridge the gap. It's also, like I mentioned before, having consultants on site, reviewing the condition of my test samples, having them provide feedback on making sure that the test samples have similar conditions, are exposed to the same natural environments, and most importantly, having the data, all calibrations completed to make sure the data is reading right. And I think once that test sample is complete, we can evaluate the information and bridge the gap, or at least push us to the right direction. Thank you.